Greetings to you. Welcome to this video presentation, Smarter Banking with AI. My name is Alvin. I worked on this project during my AI residency with Apsiva, and it's a project based on predicting term deposit subscriptions. The whole code and the output and all the nuances, you can find them in my GitHub repository. I'm going to share the link to my GitHub repository so that you can engage with it. So thank you so much for joining me. Let's get straight on to the work. Project overview and objective. Our client is a European bank which runs an outbound term deposit campaigns via call centers. The success rate historically is at 7%. So the business challenge is high operational costs due to indiscriminate outreach and low subscription rates. So the objective is to build machine learning systems that increase campaign efficiency by avoiding unlikely subscribers, that improves overall subscription success rates, and that provide interpretable outputs to support business decisions. Background: from bank to AI-driven success. The client is a European bank, and the data comes from marketing campaigns for the term deposits, and we are a startup, an AI startup that develops machine learning tools, and in this case we are using AI to predict subscription success. I might as well introduce you to our data. Basically, we have 40,000 respondents in our campaign, and we have numeric and object type data, and I just did a statistical summary of both the numeric and the object type data. For the numeric, the balance stands out there, where the minimum balance is minus 8,019 euros and the maximum is above 100,000 euros. The average is 1,274, and the call duration, where the minimum is 0, the average is 254.82 seconds, which is like 4 minutes 25 seconds, and the maximum is 4,019 seconds, which is like 82 seconds, 82 minutes long. That's quite long for a call to convince a client to buy term deposits. The object type are all categorical, and we can see the job type has got 12 unique categories in it. Our predictable variable, the alphabet Y, stands for the success, either yes or no, to the marketing campaign that we're doing. So we can see there that out of 40,000 calls, 37,104 said no to our call to subscribe to term deposits. So we did some exploratory data analysis to show or to detect class imbalance, and as we were highlighting there, most people said no, and that's 92.8%, and only 7.2 said yes. So we did univariate analysis, bivariate analysis, and multivariate analysis. So we also did some feature engineering In other words, we created new categories to enrich our data. For example, we have financial burden, which we created by seeing the number of loans one has. If one has a single loan, and if they have two loans, for example, the burden increases. If they have no loan at all, that's another category. Contact frequency, to say if a person is contacted once, then they've got a 0. If they're contacted more than once, then they've got a 1. So it's a numeric but also categorical. That's why it features on this correlation heat map that we made. We made other categories like age group. So we made from 19 to 95. We made a couple of age groups to show how in which category somebody falls into. We had groups like age of financial burden created by concatenating the age group and the level of financial burden. So we created, like I'm saying, a couple of extra columns through feature engineering, and we also did EDA after doing that. So moving on. Solution implementation, pre-processing, and feature engineering. Yeah, we did hint that we did feature engineering to enhance our data, but we also had to deal with outliers and ensure that they don't influence our models. So we came up with a two-solution approach to our problem. We came up with a pre-call workflow and the post-call workflow. So the pre-call workflow was to create a model that will help us to identify clients who are likely going to say no before we even call them. So we filter those and make sure that we don't commit our resources to people who are likely not to accept the product that we have for them. So we came up with a pre-call workflow, and the pre-call preprocessor pipeline is showing there. So for the pre-call workflow, we did not use any call-related features, but rather focused on demographic features like age balance, total loans, job, marital, education, housing, loan, age group. We used the SMOTE with undersampling for class balancing. So we used SMOTE 0.35 ratio and random undersampling at 0.5. So this helps to reduce the bias in favor of the majority class. SMOTE systemic or synthetic minority oversampling technique. And for the post-call workflow, was to identify which clients or which customers are likely to say yes, so that we can commit to those particular people who are likely to respond favorably to our campaign. So we used the nearest neighbor imputer for missing values, the robust scaler for normalization, one hot encoder for categorical features, and ADASYN class balancing, also to help reduce the bias in favor of the majority class. And we used as a ratio of 0.45 for our adaptive synthetic sampling. And we also used stratified k-fold for cross validation. Solution strategy, the modeling pipeline. So as we just said, we came up with a pre-call model and a post-call model. So The pre-call model is to filter out unlikely subscribers to reduce outreach costs. So we came up with about 8 classifiers, and at the end of the day, it was naive Bayes models that were chosen, which is complement NB and Bernoulli NB. Those were chosen for further threshold tuning for us to find the best model. So we were focusing on high recall for the no class or class 0 to avoid wasting resources. For the post-call, it's actually tree-based models that did well, and we have extreme gradient boosting model and the gradient boosting machine model, which came up tops, and we chose those two for hyperparameter tuning and for threshold tuning. So we were maximizing on the F1 score and true positives using the enriched call metadata. We went on to evaluate 2 models for pre-call and did threshold tuning, and complement NB at 0.48 emerged as the best model for the no class and recall. And for the post-call evaluation, we went on and did hyperparameter tuning to 2 models and also did the threshold tuning, and XGBoost emerged as the best model for F1 score and true positives. And we can see the final confusion matrix heat maps for the 2 models here. We proceeded with these 2 models as our best models. Segment profiling and clustering insights. So we did segment profiling and clustering for both our models, and here we're looking at the segment profiling for the post-call model, and we can see that cluster 3 is the high converting group with 35.6% chance of yes in this particular group. So it's characterized by longer call durations, moderate account balances, no loans, and financially motivated individuals. This is the cluster to prioritize, and we could see cluster 0 and cluster 4 as the highly resistant clusters, with cluster 1 being a moderate group which can be considered for periodical targeting. As we saw in May and November, this particular cluster tends to give us good results. And here we have a PCA to visualize the clusters, and we can see the green dots representing cluster 3 occupying the bottom left corner. That's where the most dominant responses in cluster 3 are found. Final project wrap-up and business recommendation. So the pre-call model, complement NB with SMOTE undersampling, helps filter out unlikely leads. Post-call model, XGBoost with ADASYN, maximizes conversion after customer engagement. Key insights: combining campaign metadata with customer features boosts targeting success. Strategic use: focus call center efforts on high potential segments to optimize return on investment. The next step is to integrate the models into a CRM system for real-time customer recommendation. So I've got a summary here to show what machine learning did for us. Before machine learning, subscriber targeting success was at 7%. After machine learning, it's about 80%. Operational time savings before machine learning, there was none. After machine learning, 389 plus hours saved via reduced call volume. Targeting efficiency, it was very limited and we had mass outreach. But after machine learning, it was a 10 times increase in targeting efficiency with fewer calls and better conversions. The cross-validated accuracy was not applicable before machine learning, but we have plus 81% on the call model using 5-fold stratified validation. I will put the links to my notebook so that you can see it on GitHub, also on Medium and on LinkedIn. Thank you so much for your time. I hope to see you in the next one. All the best.